Ready?
Yep.
5, 4, 3, 2, 1.
That was awesome.
Howdy everyone. This summer I decided to go outside my normal routine and build something a bit more experimental, a rocket-powered airplane. For some background, my mad scientist friend has been getting more and more into rocketry over the past couple of years, building his own high-powered rockets and working his way up through the levels of high-powered rocketry certification. My wife and I have even taken to building a couple of small rocket kits at the beginning of this summer so that we could feel like we were participating. The same friend also got his hands on an old-school balsa rocket glider, which was the perfect blend of his skyward hobbies. Actually, he used to have 2 identical copies of this glider, but he rapidly disassembled his first one with a ridiculously powerful rocket load. This caused the plane to, well, here.
Oh, it happened!
I've also recently rewatched a few awesome rocket plane projects on YouTube, and this summer, amongst much downtime after an unexpected injury, I decided to just go for it.
Release.
For my own approach, I had a few ideas in mind for what I wanted to do. Firstly, I wanted to start with a simple foam kit. My original idea was, well, you should be able to just shove a rocket tube up the back end of a foamie, and presto, rocket plane, right? I wanted to go with something that was a bit more approachable than balsa wood methods, yet still work with something that wasn't prepared as a ready-to-fly rocket plane kit. My second goal was to use fiberglass layup techniques to enhance the model's stiffness, and try to push the limits of what rocket speeds could be reached with the foam model. I have been slowly trying to teach myself to use composite materials in my builds. Utilizing and refining these techniques to result in a stiff, strong airframe sounded ideal for increasing the survivability of a rocket plane made out of soft foam. The model I ended up settling on was the Alpha Strike by ZOHD. At a wingspan of 620 millimeters and max weight of 900 grams, this plane is actually a bit larger than I was originally thinking, as I was thinking of starting with an ultra-small plane, somewhere around 250 grams, and eventually step up the rocket thrust until the airframe just shredded itself. But in the end, this model just had such a cool, rocket shuttle-y type of appearance that I couldn't resist pulling the trigger. I also thought that the lifting body and very low aspect ratio wing would be ideal for reaching super high speeds. And now, moving on to the build. Step 1 in this project was to integrate a rocket tube into the fuselage of the airplane. For the tube, I bought a pack of tubes from the hobby store. These would be just like the tubes that come in any rocket kit, but only come with the tubes and not the rest of the parts, such as fins, a nose cone, or the rocket mount. At first, I was considering using a 34mm tube. Upon further reflection, I decided to go a bit bigger and try to fit in a 42mm. In the end, this will give me more options to step things up in the future, and I can always adapt from the larger tube down to any smaller diameter rocket motor I wish to use. To core out the area needed for the rocket tube, I decided to try using a Hotwire bow, which I've actually never done before on a project. I first removed a rectangular chunk that matched the size of the tube. I used 2 wooden guides to perfectly align each cut. Before gluing these guides onto the center of the plane, I matched the width of them perfectly to the tube, using my table saw. Once the templates were attached, the cutting itself is quite easy, even for a noob like me. Going through it. I'm going to try doing like a little bit of slicing so that it keeps getting heat. This is my first time ever cutting anything hot wire, by the way. Just keeping a little bit of pressure on the wood as I go here. Oh, fuck. I just followed the guides, being sure to keep light pressure against the wood as I went. I used a slow sawing motion as I went too. This helps to keep the cutting edge inside the foam hot. Take any slices out back. After a couple of clean cuts and some trimming with an X-Acto knife, the foam broke free, leaving behind a perfectly sized channel with a snug fit to the tube. Did it. That was pretty sweet. That looks like I almost meant to do that. With the channel now opened up for the tube, I next cut the filler foam to fill in the spaces around the tube. For this, I used the block of foam cut out from the fuselage. I used 2 step-down adapter rings from one of my rocket kits as circular templates for the Hotwire to follow. I tacked each of these to one side of the foam piece with hot glue. It is important to pay special attention to how these 2 templates are aligned to the foam. Doing this part wrong could cause the thrust line to be out of whack and potentially make the plane pitch up or down while the rocket is thrusting. Oh, that's a little easier. Sweet. Took off and put them on the tube. And it should... Oh yeah, baby. I dry fit these foam bits in place around the rocket tube to make sure the fit and alignment was okay. Then I glued all parts in place with epoxy. I was pretty happy with the end result. The next, and by far most time-consuming part of the build, was covering the plane in fiberglass. As I mentioned before, I wanted to give the plane a fiberglass skin for rigidity. I attempted some of my first layups under a vacuum bag setup. When I've done this in the past, I used a perforated peel-off film between the fiberglass and my breather cloth. The purpose of this film is to allow the part to separate cleanly from the rest of the bag. Without it, the resin on the parts would stick to everything else and make a big mess. The challenge with this peel film is that when wrapped over complex curves, it tends to wrinkle up. When this happens, the glass and resin below will cure with a bunch of wrinkles also. What I eventually settled on doing for the remainder of the layups was to just lay the fiberglass cloth down as normal over the resin and squeegee and dab in areas that had too much resin afterwards. Then, rather than vacuum bagging the layup down, I left it to cure in the open air. This left a bit more of the woven glass texture present at the surface and might have left a bit more resin than otherwise, but resulted in a much higher quality skin with minimal wrinkles. In general, most of the surfaces are covered with a very light 25-gram fiberglass cloth. That's 25 gram per meter squared. To give additional structure around the tube, I used some 3-ounce cloth on the underside of the fuselage just below the tube. I also doubled up the 25-gram fiberglass layers around the tube on the top side. I really wanted to provide as much additional structure to this area as I could, since this area of the plane will have to transmit the loads from the rocket thrust through the rest of the airframe. I may need to add some additional structure here in the future if I want to put some ridiculous rockets in. For the wings, there's actually not a lot to say. I installed the servos first so that I could lay the glass cloth down over them without any holes in the bottom skin. I used 25-gram cloth for both the top and bottom wing skins, and I also overlapped the skins at the leading edge, trailing edge, and the wingtips so that all of these areas would be double layered. I might even go back and add some additional cloth patches at the wingtips for additional protection from rough landings and hanger rash. I elected to replace the foam elevons with balsa elevons of my own. Balsa control surfaces will be much stiffer than foam. I covered these with thin covering film, and I hinged them in with some Dubro pinned hinges. I recycled the push horns and push rods that came installed in the original foam elevons. For general assembly, the kit is designed so that the model can be broken down and reassembled after each flight. A single carbon spar runs through both wings and the fuselage, and then the wings bolt onto the fuselage from the inside. There's a plug on both of them to pass out the connection to the elevon servos as well. The fins can also be disassembled with thumb screws. While these fastening options are a nice touch, and do seem to have some thought put into them, I am probably going to glue everything together for future flights to provide the strongest possible airframe. The plane isn't that big, and I don't really need to break it down into smaller parts to get it out to the field. With the plane fully assembled, it was now time for a maiden test flight. I decided to do the maiden flight at my favorite camp and fly location, the Hill. This has been the site of many a good time flying airplanes for me in the past, and on this particular weekend, I would be in the company of 3 other rocket plane owners, so I figured I would get some solid assistance and advice on getting my build airborne. For the maiden motor, I used a 24mm D-size Estes motor. I adapted this into the rocket plane tube using a 3D printed spacer. This is a relatively low thrust motor for a model of this size, but I wanted to err on the side of starting out at a lower thrust for the maiden, to make sure the plane could survive. The launch setup was pretty simple. My Rocketman friend has a 4-pole contraption that works really well for traditional fuselage-style planes. However, the friction with all 4 poles seemed too high for this rocket plane, so we took the top 2 poles off. More on this after the launch attempt. With the plane on the launcher pointed straight into the wind, there was nothing left to do except to launch it.
Ready?
Yep.
5, 4, 3, 2, 1. No.
5. 4. Oh, thought about it. Oh.
The first ignition attempt failed. For a second try, we installed some fuse cord and lit it up with a lighter.
Okay, fly it. Fly the plane.
Do the plane thing.
Fly the plane, dude. Fly the plane. Yes!
Shit.
Yeah, dude, that was awesome. Fly the plane, dude. Fly the plane. Yes!
Shit.
And there you go.
That was awesome.
A successful maiden flight that wowed the crowds, and proof that the rocket plane concept was not completely doomed. And while there are some things that can be improved upon for future flights, I was certainly thrilled with this result. Now, let's take a closer look at the footage. Slowed down to 1/4 speed, it is clear that the launcher setup is not doing a great job at preventing rotation during takeoff. The plane clearly starts a slow yaw to the right. Once off the rails, this yaw eventually manifests in a mini stall and dip of the right wing, which I had to quickly correct via manual control. This doesn't come as much of a surprise. There is nothing in this setup to guide the plane in the yaw axis. It's just sliding on top of the poles. For future launch attempts, I am definitely going to need a more reliable launcher setup that can prevent this yawing. Another obvious observation, this D11 motor is clearly not enough rocket for this plane. I just barely had enough oomph to get off the rails and power through the initial wing rock, and once the wingtips were returned to level, there was barely any burn left to sustain any meaningful flight. There was definitely not enough energy to circle the plane back and land on the runway. Fortunately, I was able to fly the plane directly outwards from the launcher and put it down in a nice soft field. Special thank you to Tommy for marching through the plants to find my rocket plane. The next step is to work my way up to some F or G sized motor launches. If I want to go any bigger than that, I'll need to get level 1 certified, as motors larger than this require high power rocket certification. I will also be considering adding additional electronics, FPV gear, possibly a flight controller, to the nose cone to help pull more weight forward in anticipation of more rocket weight after the CG. Anyways, that's probably enough for this video. Thanks for watching, and look out for more from this project soon.